Right now, the object scientists call Oumuamua is still accelerating through deep space, defying every law of physics we have, and NASA and Harvard have no way to explain it. They tracked it. They ran the numbers 12 different ways. The numbers still don't work. But here's what nobody is telling you: the strangest part of this story isn't what Oumuamua is, it's what it did. In October 2017, a telescope in Hawaii picked up something moving through our solar system that had no business being there. Too fast. Wrong direction. Not from here. Scientists named it Oumuamua, a Hawaiian word that means messenger from afar arriving first. The first interstellar object ever detected passing through our neighborhood. It came from outside the solar system, moving at 196,000 miles per hour. It swung past the sun and continued outward into the dark between the stars. We only had a few weeks to study it before it disappeared. By the time astronomers trained their best instruments on it, it was already leaving. A thin window, a narrow chance, and in that window Oumuamua showed us something that had no place in any model of the universe we had ever built. It accelerated, not because of gravity, not from any force our instruments could detect. It just sped up. As it moved away from the sun, instead of slowing down the way every known object in space slows down, it gained speed. Something was pushing it, something invisible, something with no chemical signature, no exhaust, no radiation our telescopes could register. Every comet we have ever studied leaves a trail, a coma, a tail, jets of gas and ice as the sun heats its surface. That process creates a small but measurable push. Scientists call it outgassing. They know exactly what it looks like. Oumuamua had none of it. No coma, no tail, no jets, nothing. Astronomers at the European Space Agency cross-checked. NASA cross-checked. The Hubble Space Telescope tracked its path as it left. The acceleration was real. The cause was invisible, and that's not even the part that worries them. The obvious answer was outgassing. Maybe the instruments missed the tail. Scientists pushed hard on that explanation because the alternative was too uncomfortable to say in a press release. But the math killed it. For outgassing alone to cause that level of acceleration, Oumuamua would need to be venting material at a rate large enough to see, large enough to change its rotation, large enough that Hubble could not miss it. It wasn't rotating the way a venting object should. It was tumbling, chaotic, random, like something that had been spinning in the dark for a very long time with nothing asymmetric pushing on it. Cometary outgassing, ruled out. Solar radiation pressure, too weak by a factor of 100. Gravitational effects from an unseen object. No such object exists on that trajectory. Every conventional explanation hit a wall. Here's the strange part: it shouldn't be possible at all, but the shape fits. Oumuamua was not cigar-shaped the way early reports claimed. Analysis of how its brightness changed as it tumbled revealed something else entirely. It was flat. A thin, wide disk, possibly only a millimeter thick, but hundreds of meters across. Extremely flat, extremely light for its size. The exact geometry that engineers would design if they wanted an object to cross interstellar space using nothing but the pressure of starlight for propulsion. Harvard astrophysicist Avi Loeb ran the numbers. He published his findings in the astrophysical journal Letters. The scientific establishment responded with fury. Colleagues called it irresponsible. They called it tabloid science. Loeb didn't retract because the physics worked. A light sail, a thin reflective membrane designed to ride the push of photons the way a boat rides wind, would accelerate exactly the way Oumuamua accelerated. It would leave no exhaust, no signature, no tail. It would tumble through space exactly the way Oumuamua tumbled. No natural object in our catalogs behaves this way. No asteroid, no comet, no rogue body from any star system we have ever studied. And there is one more detail that nobody wants to say out loud. Oumuamua came from the direction of the local standard of rest, the precise averaged position of all nearby stars in our galactic neighborhood, as though it had been sitting still, waiting, stationary in space, for something to drift close enough to find. If Oumuamua is natural, then physics has a gap we cannot fill. A new process, never observed before, never seen since, created an object with no match in any catalog, accelerated it with an invisible force, and sent it through the one corner of the galaxy where beings happen to be watching. That is one possibility. The other is that something built it, something launched it. And it passed through our solar system during the exact narrow slice of history when we had instruments capable of noticing. Scientists are already searching for the next one. The Vera Rubin Observatory, a powerful new telescope now scanning the full sky, will go deep enough to catch another interstellar visitor if one appears. But the data from Oumuamua is already locked in, and no new discovery erases what the numbers say about the first one. So here is the question that stays open. If Oumuamua was a probe, And the physics says it might have been, what was it here to observe? And wherever it is going right now, is there something at the other end already waiting to receive its report?